Hello, my name is Ashley Nalda, and I'm going to show you guys how I did the ANSYS Fluent project for this propulsion class, the first assignment. So the first thing I'm going to do is walk you guys through the geometry that I did, and then the meshing, and then the setup. I will go through each one of these individually just because it takes a really long time to load, and we don't want to be here all day. So the first thing that I did is I went to the geometry, I went to the design modeler, and in here, the first thing that you should do is press this guy so you can have it in the XY plane, and then this so you can actually see the XY plane. And then going into the units, make these whatever you want them to be. I chose millimeters just for the design of my converging nozzle. It doesn't really matter just as long as you're consistent with it. And then this part here, I used the polyline tool in the sketching, so I went from here, so to sketching, and then polyline, and then from here to there, and then from here to here, here to here, here to there, and then there, and then there. And then I right click, press close end. This way I have all of it. It might look a little crazy right now, but we're going to give it dimensions and then constrain it to be symmetrical across the x-axis. So the first thing I'm going to do is give these guys some length. So I want here, so I went to dimensions, length and distance, and then clicking the dots here is the most important part from here to here. That's good. And then I need the throw area, so there's this part here. Then I care about the exit area. I care about the length of my total nozzle, and I care about the length of the diverging part. So, perfect. And then okay, there we go. I don't know why that's like that, but that's fine. So then changing the lengths of these to be what I want them to be. So this one's going to be 25. This one's going to be 10. The exit area will be 35. And then this is going to be 75. And then this is going to be 50. Okay, it might look crazy, but we're going to go ahead and constrain these now. So constraints, and I'm going to do symmetry. So I'm going to press the x-axis here. The first one I'm going to do is this one. Oh. Okay, wait. So this one's going to be 50. Okay, and now constraining it again. So symmetry from here to here. I want this and that one, and then this point and that point, and then this point and this one. Perfect. So now that that's like that, we're going to go ahead and press concept, surfaces from sketching. I'm going to press this, then I'm going to press apply, then I'm going to press generate. Perfect. Now that that's done, we are going to go ahead and start to split up these sections, right? Because I want to split it up to the converging section and then the diverging section. So what I'm going to do here is, now that this is generated, I'm going to go ahead and click this. I'm going to press look at. It should turn green. And then from here, we're going to go to this part here. So press look at. I'm going to zoom in just so I can see what I'm doing. Then I'm going to go to sketching. The orientation of this, however it shifts it, doesn't really matter, because it might, sometimes it just switches itself up. So it doesn't matter as long as it just looks like this. And then we're going to draw lines here. I'm going to draw a line from here and a line to here. Perfect. And then I'm going to go to modeling. I'm going to go to Tools, and I'm going to go to Face Split. I'm going to select my whole guy and hit apply. And then the part that I'm separating at, I'm going to press from here to there. Perfect. I'm going to press apply. And then we're going to press generate. And then to make sure that you did this right, you're going to go up to these these 4 boxes, you're going to press this one. It should separate it into 2 halves now. Perfect. Beautiful. So now we're going to do the same thing, and now we're going to make it a little bit farther from this center line, because the stuff that's interesting that we care about will happens at the throat. So I'm going to go ahead and do the same thing that I just did. I'm going to go to sketching, and, oh, hold on, 1 second. So, look at it. Okay, modeling, press this again, right? Perfect. Okay, now here, now press look at. Once this is green, press look at. And then we're going to go to sketching, line, and we're going to draw a line from here to here, and then again from here to here. Once again, it doesn't matter if these are parallel or not. The whole point is that they're parallel to this vertical line here in the center that we did to separate the converging part to the diverging part. Now we're just going to constrain these, make these parallel, and then split it again using the face split tool in the modeling part. So going from here to constraints, I want this parallel to that. Perfect, it should do it, and then this parallel to that. Perfect. Now we're good. So now I'm going to go back to modeling. I'm going to go back to tools, back to face split. I'm going to select this as my face now. Because we separated in 2, now it can just continue to separate. So hit apply. Ooh. Apply. And then the part that I want to separate it at is from here to here. And then apply. Ooh. From here to there. Perfect. And now apply. And then generate. And I'm just going to wait and hold on to that for a second. And then I'm going to do tools, face split again. I'm going to go to this part here, press apply. And then from here to here, I want from this point to that point, and then press apply, and then generate. You should have a total of 4 sections now. To check that you did this correct, we're going to go 1, 2, 3, 4. Perfect. And now we need to make some lengths here. Ooh, I probably should have done that before. Okay, hold on. Alright, now that we have the geometry set up, we can go ahead and go into the mesh. So in here, I've already updated everything and edit and whatever. So we're going to go to edit, and don't press anything until that's done. Okay, hold on, still thinking about it. Perfect. So going here to this, we're going to go ahead and start by selecting all of our vertical points. So going from here, we're going to go here, and we're going to press this edge control, and then we're going to hit control and go like this, and we're going to go here and we're going to press insert, click out of this, and we're going to go to meshing method, and we're going to go to go here, and then we're going to press meshing method, mesh, There we go, mesh, and then you want to go to method. Okay. Then we're going to go here, and then we're going to press this, our whole guy, hit apply. And then we're going to use quadrilateral dominant, but we're going to make this all quad here. And we're going to go through, and then we're going to press the vertical sections again. And go here, and then you have to press Control to go ahead and do that. And then you're going to right click, go to Insert Sizing. And then here where it says Type, you're going to go to Divisions. And I'm going to make this 30. And that should be good. And then we're going to do the same thing for the walls. So then now that that's set up, we're going to press out of this and we're going to go to here again. Actually, let me go to generate. And then, perfect. And then we're going to do the same thing, press here, Control, pressing all of these. Same thing here. Insert sizing. Same thing, we're going to go to number of divisions, and I want this to be 20. Enter. And generate. Perfect. And you can go here and you can see the difference in this. And now we're going to go ahead and name our selections, like the front, the inlet, and the outlet, and the wall, so that we can go ahead and call on them in a second. So now that we have this here, I can go here and I can press update. Perfect. It should look like that. And we're actually going to structure this guy first. So we're going to go here to the face selections, and we're going to press all of them. We're going to press Control by going like this, like this, like that. And then it's going to go to Insert. We're going to go to Face Meshing. And we're going to go to we're going to keep this as quadrilaterals, and then we're just going to go to Mesh, Update, and they should be squares in a second. Beautiful. It should look like that. And now I'm going to go ahead and name my inlet, my outlet, and my walls. So I'm going to go here and press this guy and click that, and then I can just press N. Oh, hold on. Right click it, or left click it, press N, and then I can name this inlet. Press OK, and then I can go here, press N, name that outlet, and then I can go to here, and then while pressing Control I can name all my walls, and press N, and then I can go walls. Perfect. And when I want to make sure that I name them correctly, I can go here and I can press each one. And that's beautiful. Perfect. And now we can go ahead and close this out. Close meshing. Okay. This might take a second to update, so I'm going to go here into this setup. It's the same mesh as before, same geometries and everything. We're just going to go here, and then I'm going to press Edit. I want this in dull precision, and I'm going to make this a 2. And press Start. Okay, I'm still gonna let it think about it because nothing is actually loaded here. Perfect. So press OK. Alright, okay, so we're gonna go to density based, and then we're gonna do transient. That perfect, looks good. Actually, no, let's keep that pressure based. We're gonna go to general, models, energy, we want this guy on, and press OK. Viscous, we want inviscid. Look perfect, like that. Then materials, we're gonna go here and we're gonna go to fluid. We want air. And then we're gonna make this ideal gas. These are gonna stay the same. Change, and then close. And then we're gonna go to our boundary conditions. I want this to be a pressure inlet. And then it's going to let me do this. For my normal shock, not my normal shock, let me make sure that I have these correct. So for the isentropic case, these are the values that I use. Just want to make sure that I'm telling you the right stuff. Oh, okay, wait. Here, okay, so this one, I use 9.7, what was it? I used, 97 megapascal, so 9.7, 1, 2, 3, 4, 5, 6. And then making this the same, 1, 2, 3. And then this was 3710. 3710 Kelvin. Press apply, close, and then same thing. I want hold on, this one's a little bit. Alright, so now this is going to the actual setup, so how you can get the velocity, the different contours for velocity, the Mach number, the pressure, all of them, the ones that Ozbay asked for, and same thing with the plots. So once you have these little green check marks, you're going to have a little electric symbol, a little lightning bolt. That means you have to update it. So once it's updated and you've done all that, you can go here and then you can press edit. And it's going to think about it. You want this double precision. I'm just going to make this a 2 and press start. Okay, perfect. And I know that this looks right because I have arrows going in and out, so that way I'm able to, set up my pressure at the inlet and my pressure at the exit, and you can modify those. If you want a normal shock, you can just start increasing that back pressure or your exit pressure. And then for the normal shock, for the isentropic case, I just made the exit pressure your atmospheric pressure. So I'm just going to exit out of that. And then pressure base, fine, absolute, great, steady, great, planar, perfect. So then I'm going to go to models here. And then I want energy, I'm going to turn this guy on. And then this, I want this to be in viscid flow. Perfect. And then that's all we need to do there. And then going to materials, fluid, air. I want this to be an ideal gas. And I'm just going to keep all these because that's true. Then change, create, close, and then boundary conditions. Perfect. I have my inlet and my outlet. That's all I need. So this guy here, I'm going to go ahead and change this type to be a pressure inlet. And absolute is fine. I made this 97 megapascals, so this is going to be E to the power of 6. And then I'm just gonna, I don't trust that. So 1, 2, 3, 4, 5, 6. And then same thing this one. And then this I made 3710. Then pressing apply, and then close. And then going to the same thing here. This should also be already a pressure outlet. Once you change the inlet, it should change them both to be the same. So then going here and then editing this. This is absolute total. This I made 101325. That's just atmospheric pressure, normal boundary, and then I wanted total pressure, and then thermal. I just made this the same. Nope, static pressure. And then I made that close. And then we're gonna go to monitors. We're gonna go to residual here. We're gonna make all of these this. Then we're gonna press OK. And then we're gonna go to initialization. And let it think about it. Okay, so then we're going to go to standard. We're going to compute this from the inlet, and then, yeah, yes, yep, that looks right. We're going to press initialize. The values for your gauge pressure and your temperature should be your inlet values if you are computing it to from the inlet. So just likes to think about it. Perfect, it did it. So yeah, it did do it. Okay, so, and then we would hit to run calculation. But that's going to take such a long time. So I already have it here. When you run your, yeah, once you run everything like that and change everything. Oh, I'm sorry. In this, I added an extra 0. Okay, hold on. In this one, I added an extra 0. Let me just change that really quick. Just so that they are all the same. There's that, and that one's like that. Perfect, and then close. So this one will give me the same stuff now once I go to my initialization. Just gonna think about it. So, but that was the only difference in this one and this one. Just wrote an extra 0. So once again, these values should be the same. And once you press and run calculation and do everything, it should do that. Now, once you have everything calculated, we can go to our contours and our XY plot to get the different contours. So from here, right now I have the static pressure. So the static pressure is already on here. The one that I know that should be different because they behave in opposite, they have opposite properties to the Mach number and the velocity. So I'm going to pull up the Mach number and it should be the inverse of these colors. So I'm going to go ahead and hit this guy, velocity. I'm just going to do velocity to show you that it's in, the Mach number's in here. So I'm going to go here and I press save display. Yep, and it should be the inverse of that. And then to do the, just to show you another one, density should be the inverse of the Mach number. So density, save. Perfect. Yep, that looks right and that behaves how I expect it to. And then closing this guy out and then going to my XY plot. What do we want here? So when you do this, you have to create a center line here so that you can get it along the center of the axis. So that would be line 7 for me. all you're going to do is press new surface line rake, and then you're just going to press create here. I already have it, so there's no reason for me to redo that, but when you just hit create, it should do it along the center automatically for you. So here we go. I'm going to get pressure. Sounds good. We're going to go to save plot. Perfect. The pressure is going to be decreasing right along the center. Perfect. And then just to do a different one to show you that they're going to be inverse. So let's do the velocity. Let's do velocity, magnitude, save plot. Perfect. They are inverse. This is working exactly as it should. And once I use the snipping tool to get all of my plots, this is the difference here between each one. And then following the exact same.
Do you mind coming up to help for grading students?
Then following the exact same process with a normal shock, just making this back pressure higher than isentropic, right? Than the isentropic. Just increase that and keep increasing that until you get something that looks like this. The back pressure, you can calculate it, or you can just keep increasing it depending that you know that it should look something like this. Thank you.